A 74-meter yacht designed to rise above the water and reach 75 knots uses hydrogen power and an adjustable foil system to pursue a radically different way of moving at sea. Plectrum is a 74-meter superyacht concept created by Italian designer Pier Paolo Lazzarini, built around an unusual idea. Instead of simply pushing through the water, the yacht is designed to lift above it. Its key technology is a foiling system, inspired by the high-speed boats used in America's Cup racing, including Prada's 2023 design. As Plectrum accelerates, its adjustable foils generate lift, raising the hull above the surface and allowing the yacht to target speeds of up to 75 knots. Power comes from 3 hydrogen-powered motors, each producing 5,000 horsepower. Together, they deliver a remarkable 15,000 horsepower. But the most interesting detail is hidden beneath the yacht. The foil system can change its width according to the operating condition. When closed, it measures around 15 meters. Underwater exploration demands more than strength. It requires precise propulsion, reliable information, and technology that can keep pace with every movement. Subblue vapor. Moving underwater becomes a very different challenge when every meter requires constant effort. The subblue vapor tackles that problem with a powerful propulsion system producing 210 newtons of thrust. Its 6-blade impeller and rear guide vanes help deliver smooth, consistent power, pushing the scooter to speeds of up to 6.2 miles per hour across 3 adjustable modes. Power comes from a removable 29.6-volt, 13,000 mAh battery, providing up to 60 minutes of operation and recharging in about 1.5 hours. Designed for controlled movement, the vapor can operate at depths of up to 40 meters while helping reduce sudden depth changes. A 4.3-inch display keeps important information visible, including speed, battery level, direction, depth, and water temperature, with alerts for depth limits. Then the focus shifts from propulsion to performance. A passenger vessel built for resort travel is taking a very different route across the water, rising above the surface to make the journey quieter, smoother, and more efficient. Artemis EF-12 Escape. A passenger vessel built for resort travel is taking a very different route across the water, rising above the surface to make the journey quieter, smoother, and more efficient. The Artemis EF-12 Escape is designed specifically for resort transportation, where the experience of getting from one destination to another can be just as important as the destination itself. But what makes this vessel unusual is not simply its size or passenger capacity. It is the way the boat moves. At the heart of the design is Artemis Technologies' patented EF foiler technology. Instead of traveling with the hull constantly pushing through the water, the vessel uses underwater foils to generate lift as it moves forward. Once operating on its foils, the boat can glide above the water's surface, creating a smoother and quieter ride. That approach also gives the EF-12 Escape impressive performance for a passenger vessel of its type. What if your hotel room could leave the shoreline behind, drift into a quiet stretch of ocean, and still provide the comfort and technology of a luxury suite? Lazzarini Pearl Suites are designed to bring luxury hospitality directly onto the water, combining a compact floating space with modern sustainable technology. Created by Italian designer Pier Paolo Lazzarini, each circular pod measures around 22 square meters and can include a bedroom, kitchenette, bathroom, and customizable interior. Large panoramic views keep the surrounding ocean at the center of the experience, while a retractable windshield can open the space even further to the seascape. But the concept goes beyond comfort. Solar panels, optional hydrogen fuel cells, and onboard energy systems are designed to make the suite highly self-sufficient. A small electric motor also allows the pod to cruise under GPS guidance or remain anchored at a selected location. Because these suites are modular and movable, resorts could potentially expand across the water without building extensive permanent infrastructure. A ship crossing the ocean without relying on conventional fuel is testing whether sunlight, wind, water, batteries, and hydrogen can work together as one energy system. Energy Observer is more than a vessel. It is a floating laboratory built to test how renewable energy can power life at sea. Its system combines solar panels, wind power, and hydropower, creating electricity from several natural sources instead of depending on conventional fuel. But producing energy is only half the challenge. The ship also needs to store it when conditions change. That is where its 2-stage storage system becomes important. Batteries handle short-term energy needs, while hydrogen provides longer-term storage. Hydrogen can preserve energy for periods when renewable sources are not producing enough, giving the vessel greater energy independence. During its journey, Energy Observer operates as a real-world testing platform, exposing these technologies to demanding marine conditions. Its experiments explore whether decentralized, low-carbon energy networks can work beyond the laboratory. A swimming pool can now become a gateway to underwater worlds, using virtual reality to turn ordinary laps into an interactive exploration without leaving the water. Ballast DIVR. Developed by Ballast VR, brings virtual underwater exploration into ordinary swimming pools and water parks. Instead of simply swimming from one side to another, users wear a waterproof VR headset and enter digitally created underwater environments. As they move through the pool, the headset provides an immersive visual experience, allowing swimmers to explore different worlds and interact with elements around them in real time. The system is designed to keep movement controlled and stable, with pool safety remaining an important part of the experience. Another advantage is its practical setup. Ballast DIVR requires relatively little space and can be introduced at aquatic facilities with straightforward staff training and installation that can take as little as a day. For resorts and aquatic centers, a cargo ship designed to move goods without a crew or direct emissions is changing what engineers once expected from short-distance maritime transport. Yara Birkeland. The Yara Birkeland is built around a simple but ambitious idea: move cargo by water using electric power and autonomous technology instead of relying entirely on road transport. Its electric propulsion system allows the vessel to operate with zero greenhouse gas emissions during operation, making it a cleaner alternative for the type of cargo movement it was designed to handle. But the most unusual feature is what happens on the bridge. The ship uses cameras, sensors, and artificial intelligence to understand its surroundings, navigate its route, and assist with docking. These systems are designed to reduce the need for onboard crew as autonomous operation develops. The vessel also carries cargo between locations by water, helping shift transportation away from roads and potentially reducing emissions associated with road freight. Together, electric propulsion and automated navigation make the Yara Birkeland an important example. Keeping a lake healthy can mean constantly tracking invisible changes in the water, but EcoBot 500 approaches that challenge with an autonomous system that can monitor and clean as it moves. EcoBot 500 is an AI-powered aquatic robot built to tackle one of the most persistent problems in lakes, rivers, and reservoirs: green algae and declining water quality. Instead of relying entirely on human crews, the autonomous robot can move through the water while identifying algae and other organic pollutants. But its job goes beyond cleaning. A network of onboard sensors continuously monitors water conditions, collects samples from different depths, and helps the system recognize objects in its path. Power comes from a 24 kWh battery, supported by a 2.52 kWh solar panel, allowing the EcoBot 500 to operate using a more sustainable energy setup. The robot can also connect with a centralized monitoring and control system, giving operators remote access without requiring someone on board. According to the supplied specifications, EcoWave Power is turning the constant motion of ocean waves into electricity, but keeping those systems working efficiently requires a second technology operating above the water. EcoWave Power is developing a different way to produce clean electricity by capturing the natural movement of ocean waves. Its patented floaters are designed to convert wave motion into grid-ready power, with projects in Los Angeles, Portugal, and Taiwan, while its global project pipeline exceeds 400 megawatts. But generating energy from the ocean is only part of the challenge. These systems also need regular inspection and maintenance, and that is where Blade Ranger enters the picture. Blade Ranger specializes in autonomous drones that can inspect, clean, and support predictive maintenance for renewable energy equipment. During a live demonstration at Jaffa Port in Israel, Blade Ranger drones inspected and cleaned EcoWave Power's floaters, the components responsible for capturing wave energy. The partnership could help reduce maintenance costs. A ship designed to move vehicles, launch drones, operate helicopters, and survive contested waters has to do far more than simply travel through the sea. Stellar Systems' Fearless MRSS concept begins with a remarkable combination of size, speed, and flexibility. With a full load displacement of around 15,500 tons, The vessel is designed to reach more than 30 knots while covering up to 7,000 nautical miles at 18 knots. But its real strength is how much it can carry and deploy. Inside, the ship provides about 800 lane meters for vehicles, supported by a stern ramp for moving equipment on and off the vessel. It also includes a side launch system designed for deploying drones, adding another layer of operational flexibility. Its defensive capabilities include medium-caliber guns and missile silos, while the aviation facilities can accommodate 2 Merlin helicopters or a combination of helicopters and UAVs. That versatility allows the fearless MRSS to support missions ranging from mine warfare to humanitarian operations in contested waters. Most boats fight against the water every second they move, but one futuristic design takes a completely different approach by barely touching the surface at all. Meet the Eldorado 8S prototype hydrofoil. At first glance, it looks like a modern luxury boat, but its biggest innovation stays hidden beneath the water. Instead of pushing through the waves like traditional boats, the Eldorado 8S uses underwater wings called hydrofoils. As speed increases, these foils lift the hull above the surface, reducing water resistance and creating a smoother, quieter ride. That lower drag also helps the boat travel more efficiently while using less energy. Power comes from a fully electric motor, producing zero direct emissions and far less noise than conventional gasoline engines. Inside, the Focus is just as impressive, with premium seating, a spacious swim platform, and luxury touches designed for comfort on the water. By combining hydrofoil engineering with electric propulsion, the Eldorado 8S offers a glimpse of how high-end boating could become cleaner. Most sightseeing boats show you the world above the water, but one unusual design reveals what lies beneath the surface while making the journey faster, smoother, and surprisingly more efficient. Meet the Boat Looker 320. Built for coastal tourism, the Boat Looker 320 offers passengers a rare view of the underwater world without leaving their seats. Its large transparent glass bottom section allows people to observe marine life and underwater landscapes during sightseeing tours. The experience becomes even more impressive once the boat gains speed. Using hydrofoil technology, underwater wings lift the hull above the surface, reducing water resistance. With less drag, the ride becomes smoother, fuel consumption decreases, and passengers enjoy greater comfort even on longer trips. To support commercial operations, the boat includes practical features such as hydraulic steering for easier control, a fuel meter for monitoring performance, comfortable steering seats. For decades, cities searched for a faster way to move people across busy waterways without creating noise, pollution, or damaging waves. One electric vessel is finally making that vision practical. Meet the Candela P12, an electric passenger shuttle designed to transform urban travel on the water. Instead of pushing through the waves like a traditional ferry, it rises above them using underwater wings called hydrofoils, reducing drag and creating a smoother, quieter ride. That clever design allows the P12 to cruise at 25 knots while covering up to 40 nautical miles on a single charge. Measuring 11.99 meters long, it is powered by 2 Candela C-Pod electric motors, delivering efficient performance with minimal maintenance. Inside, the vessel accommodates 30 passengers with premium seating that can be customized for public transport or private operations. Energy comes from 463 kilowatt-hours battery packs. Beneath the ocean surface, distance becomes a challenge for every diver, but a compact machine is changing how explorers travel through underwater worlds with less effort and greater control. Diver Propulsion Craft. Deep underwater, every movement requires energy. For divers exploring large areas or fighting powerful currents, swimming alone can become exhausting. This challenge led to the development of the Diver Propulsion Craft, a compact underwater scooter designed to help divers move more efficiently. Instead of relying only on their fins, divers can hold onto this motor-powered device as it pulls them through the water. This allows them to travel farther, explore wider underwater locations, and conserve energy during longer dives. Diver propulsion crafts come in many designs. Some are small and portable, built for short trips and easy transport, while larger enclosed models can carry multiple divers over greater distances at higher speeds. However, these machines require proper training and careful operation. A boat designed to travel farther while depending less on traditional energy sources is showing how solar power, efficient engineering, and smart systems can reshape modern marine travel. The Earthling Stealth E40 represents a new approach to electric boating, combining clean energy technology with practical marine engineering. Instead of relying only on external power sources, this catamaran is designed to collect and manage energy more efficiently. At the heart of the E40 are Earthling's e-propulsion and ethos systems. These technologies work together to improve energy use by capturing solar power, supporting wind energy, and providing onboard hot water. The goal is to create a more independent boating experience while reducing unnecessary energy consumption. But the E40 is not just a concept. It is a real production boat built using proven manufacturing methods and reliable components. Its design takes inspiration from the Stealth 36 Powercat. When a 24-meter vessel leaves the shoreline, it doesn't simply cut through the water. It rises above the surface, carrying passengers and cargo on a cushion of air. Griffin Hoverwork 1200TD. The Griffin Hoverwork 1200TD takes a very different approach to high-speed transport. Instead of relying entirely on a conventional hull moving through the water, this hovercraft travels on a cushion of air, allowing it to operate across water and suitable land surfaces. At roughly 23.7 meters long, the 12000TD is built for serious transport work. Its twin-man diesel engines provide the power needed to lift and propel the craft, while the design integrates both functions into a compact propulsion system. With room for around 80 passengers and a payload of up to 12 tons, it can serve both passenger ferry routes and cargo operations. At full payload, the craft can reach about 45 knots, giving it impressive speed for its size. Most boats force owners to choose between speed, comfort, or size. This compact vessel quietly combines all three, raising an interesting question about what modern yacht design can truly achieve. Meet the Jet Capsule, a compact luxury boat designed to deliver the comfort of a yacht without the bulk of a traditional vessel. Its body is built from 70% carbon fiber using vacuum infusion molding, a manufacturing process that creates a strong yet lightweight structure for better efficiency on the water. That lightweight design works alongside multiple hydro propulsion options ranging from 370 to 740 horsepower, allowing the jet capsule to reach speeds of up to 35 knots while maintaining a smooth ride. But performance is only part of the story. Inside, an air-conditioned cabin comfortably seats 6 passengers, while customizable layouts can include a kitchen, bathroom, and sleeping space for longer trips. Photochromic windows automatically darken in bright sunlight, improving privacy and comfort. Add features like shock-absorbing seats. For decades, boat designers searched for the perfect balance between speed and stability. The Kron K7 takes a different approach by changing the way a vessel moves across water. The Kron K7 is not designed like a traditional boat. It represents a new approach to marine engineering, combining performance, stability, and advanced materials into one unique vessel. The challenge was simple but difficult: create a boat with the speed of a monohull while maintaining the smooth stability of a catamaran. The K7 achieves this balance through an adaptive design that can change its configuration while underway. Inspired by America's Cup hydrofoil technology, the vessel uses advanced systems to reduce contact with the water and improve efficiency. Its lightweight carbon fiber structure, built with automotive-level precision, helps lower weight while increasing strength. The result is a boat that can dramatically reduce water resistance and improve fuel efficiency compared with conventional designs. Produced as a highly limited first edition, one board is changing the way people experience the water, combining electric power, precision control, and surf-inspired design into a machine built for speed without needing ocean waves. Onin Carver X is an electric surfboard designed to bring the excitement of surfing to almost any body of water. Instead of depending on waves, this advanced board creates its own movement using a powerful electric jet propulsion system. The motor can push riders to speeds of up to 40 km per hour, giving the board enough power for fast cruising and dynamic carving. Riders control the experience through a wireless remote, allowing them to adjust speed and power while moving across the water. But performance is only part of the design. The Carver X includes a safety system that automatically stops the motor if the rider falls, helping reduce accidents during operation. Built with premium materials like a carbon fiber body and teak deck, The board is designed to be lightweight, durable, and waterproof. Its battery can provide around 40 minutes of riding time on a single charge. Whether it is used for cruising, carving, or practicing surf-style movements. Meet the Pangios Terriot. This incredible floating structure is one of the most ambitious ocean projects ever imagined. Designed by Pier Paolo Lazzarini and Lazzarini Design Studio, this giant turtle-shaped yacht could become the world's largest floating city. The Pangios Terriot is planned to be around 550 meters long and 610 meters wide, making it even larger than many famous landmarks. It could provide homes, luxury spaces, hotels, and entertainment areas for up to 60,000 people at the same time. But what makes this project truly futuristic is its focus on clean energy. The design includes powerful electric engines, solar panels, and special systems that help it move through the ocean while reducing pollution. The floating city would be built in a specially designed shipyard and could travel at a slow but steady speed across the seas. With an estimated cost of billions of dollars and years of construction, this project represents a completely new vision for future living. Most people experience the ocean only from above, but one unusual vessel quietly changes that perspective by letting passengers descend beneath the surface without ever learning to dive. Platypus Craft. Exploring the underwater world usually requires diving equipment and special training, but the Platypus Craft offers a completely different experience. This unique electric vessel is designed to bring passengers closer to marine life, colorful coral reefs, and underwater landscapes while keeping the ride simple and comfortable. Its most impressive feature is a movable center section that lowers the cabin beneath the water, transforming the craft from a multi-hull boat into a semi-submersible in just moments. Once in the water, a jet drive system powers the vessel, while handlebar controls make steering straightforward even for new users. The electric battery provides up to 4 hours of operation, giving plenty of time to explore coastal waters. Inside, there is room for 4 passengers to enjoy the underwater views together. Built by the French company Platypus Craft, a small electric boat reaches speeds normally associated with much larger vessels by lifting its hull above the water, revealing a different approach to efficient travel across the waves. Proteus 360. The Proteus 360 takes a different approach to electric boating. Instead of pushing its entire hull through the water, its hydrofoil system can lift the boat above the surface, reducing drag and helping it travel more smoothly. At the heart of the boat is an electric motor producing 5 kilowatts of continuous power, with a peak output of 14 kilowatts. In hydrofoil mode, the Proteus 360 can cruise at 20 knots and reach a top speed of 26 knots. Power comes from a 15 kilowatt-hours battery, providing up to 85 nautical miles of range, while a full recharge takes around 2 hours. The boat also offers 3 operating modes: displacement, foiling, and transport, allowing it to adapt to different conditions. Smart electric steering provides precise control. IT was built to prove that electric power can compete on water, but the secret behind its incredible speed is a technology that allows the boat to rise above the waves instead of fighting through them. Racebird is the electric racing boat created for the UIME-1 World Championship, where speed and efficiency meet advanced marine engineering. Unlike traditional boats that push through the water, Racebird uses a special hydrofoil system that lifts the hull above the surface at high speeds, reducing resistance and helping it move more efficiently. Powered by a battery system delivering up to 350 kilowatts, this futuristic boat can reach speeds of more than 60 miles per hour while producing 0 direct emissions during operation. Its lightweight structure plays a major role in its performance. Measuring 5.5 meters long and 2.4 meters wide, Racebird weighs around 800 kilograms and is built using strong materials like carbon fiber and Kevlar. Inside the center cockpit, a single driver controls every movement through a steering wheel, throttle, and brake pedals. Beneath the surface, this tiny submarine replaces a conventional engine with human power, turning underwater exploration into a surprisingly agile and almost silent experience. SCER. At first glance, the SCER looks like a miniature submarine built for a very unusual kind of underwater journey. Created by French engineer Stéphane Roussin, this compact vehicle gives divers and aquarists another way to explore beneath the surface. Instead of relying on a traditional engine, the SCER moves through the water using pedal-powered propulsion. The user's own effort drives the vehicle forward, providing an environmentally friendly way to travel underwater while also making movement remarkably interactive. Its streamlined, hydrodynamic body is designed to reduce resistance as it moves through the water. That shape allows the SCER to handle diving and underwater acrobatic movements with greater efficiency. The structure is made from lightweight carbon fiber, helping improve durability while supporting buoyancy control, performance, and safety. Beneath the ocean's surface, a new generation of personal technology is allowing people to move through water with the freedom of a diver while capturing every moment in incredible detail. Seabob is one of the most advanced personal underwater scooters designed for people who want a faster and more exciting way to explore beneath the waves. Unlike traditional diving equipment, this compact electric watercraft lets riders glide through the ocean while holding onto handlebars and controlling movement with their body position. Powered by a quiet electric motor, Seabob delivers a smooth and emission-free ride with different speed settings for beginners and experienced users. Some models can reach depths of around 40 meters when used with proper training and certification, opening the door to a unique underwater adventure. But exploring is only part of the experience. The GoPro Max helps capture these underwater journeys with immersive 360-degree footage, allowing every movement and surrounding detail to be recorded. Together, Seabob and GoPro Max combine exploration and storytelling. Seabreacher turns a watercraft into something that moves more like an aquatic predator, combining high-speed surface travel with the ability to dive, jump, and carve underwater. Seabreacher is not built like a conventional boat. Its design is inspired by aquatic animals, allowing it to dive, jump, and carve through the water with surprisingly dynamic movements. Built as a high-performance semi-submersible watercraft, the Seabreacher comes in several models, including the X, Y, and Z series, each offering different capabilities and configurations. But its most impressive feature becomes obvious when the throttle is opened. On the surface, its powerful engine can push the craft to speeds of around 60 miles per hour. Once submerged, it can continue moving underwater at approximately 20 miles per hour, creating an experience that feels closer to piloting a marine aircraft than driving a boat. Inside, the fighter jet-inspired cockpit is enclosed beneath a panoramic canopy, giving both pilot and passenger an immersive view while advanced controls provide precise handling. Far beyond short weekend rides, modern watercraft are being engineered as compact adventure machines, combining powerful performance, smart storage, and long-distance capability on open water. The Sea-Doo Explorer Pro 170 was built for riders who want to travel beyond ordinary waterways and carry everything needed for longer adventures. Behind its design is a focus on distance, comfort, and control. Power comes from a naturally aspirated 1630cc Rotax Ace engine producing 170 horsepower. Working with a closed-loop cooling system and electronic IBR reverse technology, it delivers reliable performance while making low-speed handling easier. The machine sits on Sea-Doo's ST3 fiberglass hull, a platform designed for stability even in challenging conditions. Weighing 880 pounds, it can carry up to 3 passengers with a total capacity of 600 pounds. But the Explorer Pro 170 is not only about speed. Meet the Silent Tender 400, a small all-electric boat made to perfectly support modern solar-powered yachts while offering a completely quiet ride on the water. At just 4 meters long and weighing only 90 kilograms thanks to its carbon fiber build, this tender is light, strong, and very easy to handle. It can carry up to 6 passengers, giving everyone a comfortable and stable ride. Inside, the design is clean and simple. You get a leather-wrapped steering wheel and a digital display that shows your speed, direction, and water depth in real time. Boarding is also made easy and safe with a smart lowered step built into the side. For performance, you can choose between a 20 kilowatts electric water jet for smooth cruising or a more powerful 20 to 30 kilowatts outboard setup if you want extra speed. It can reach over 20 knots with ease. With 16 or 20 kilowatt-hours lithium batteries, you get around 2 hours of cruising at 10 knots, and it fully recharges in just 2.5 hours. Most boats ask you to choose between comfort and performance, but one pontoon quietly combines both, proving that smart engineering can completely change a relaxing day on the water. Sylvan M5 CRS is built for boaters who want luxury without giving up confident performance. At first glance, it looks like a stylish leisure pontoon, but several clever features make it far more practical than expected. On the starboard side, owners can add a compact galley complete with a freshwater sink, countertop, and dedicated wine bottle storage, making long days on the water more enjoyable. An extended rear platform creates extra space for swimming or relaxing, while the rear lounge seat quickly transforms into a private changing room for added convenience. Underneath, 3 durable 25-inch pontoons paired with lifting strakes help the boat stay stable, improve cornering, and provide a smoother ride across the water. The Sylvan SPX performance package works alongside a reliable 100 horsepower inline 4-stroke engine, delivering balanced handling and dependable cruising. And that's only part of what makes this premium pontoon stand out. For centuries, sailing has depended on wind and water, but the AC-75 pushed engineers to redesign the yacht itself, creating a vessel that can lift above the waves at incredible speeds. The AC-75, America's Cup yacht, is one of the most advanced racing boats ever created for competitive sailing. Introduced for the 2021 America's Cup, this 23-meter vessel changed traditional yacht design by replacing the classic multi-hull approach with a single hull structure. What makes the AC-75 unique is the pair of massive hydrofoils beneath the boat. These wing-like structures lift the yacht above the water, reducing drag and allowing it to reach extreme speeds while maintaining control. Instead of a conventional rigid sail, the AC-75 uses a soft-wing sail system designed to deliver powerful performance while keeping the principles of traditional sailing. The yacht also operates without a traditional keel, depending entirely on its hydrofoil system for stability. For decades, exploring the deep ocean required massive machines and professional crews, but a compact submersible is changing how individuals can experience the underwater world. U-Boat Works Nemo. Deep beneath the ocean surface, exploration has always been limited by the size and complexity of traditional submarines. The U-Boat Works Nemo takes a different approach by creating a compact 2-person submersible designed for recreational diving and underwater discovery. Built for a pilot and 1 passenger, the Nemo allows people to share the experience of exploring marine environments together. Unlike many larger submersibles, this model focuses on portability, weighing around 2,500 kilograms and taking up a space similar to a jet ski, making transportation and storage much easier. The Nemo can dive to depths of 100 meters, opening access to a wide range of underwater locations. Its 4 electric thrusters provide quiet movement, precise control, and smooth hovering beneath the surface. By combining safety, simplicity, and practical design. For decades, wheelchairs were designed only for land, but artist Sue Austin created a device that allows movement in a place where mobility seemed impossible, beneath the ocean's surface. Sue Austin's underwater wheelchair is an extraordinary project that combines art, technology, and accessibility in a completely new environment. After losing the ability to walk, Sue Austin began exploring new ways to experience movement. Her solution was an adapted wheelchair designed to travel underwater, allowing her to glide through the ocean instead of being limited by traditional mobility barriers. The chair uses underwater propulsion systems, with specially designed controls that help steer and change direction. Powerful motors and fins attached near her legs allow Sue to move gracefully through the water, creating the feeling of flying beneath the surface. Named Finding Freedom, the project was created to change how people view wheelchairs and disability. Rather than representing limitations, Sue's underwater wheelchair presents them as tools for exploration and independence.